Good morning, everyone. Good evening, everyone. So today the session, I would like to invite the session chair, Hardik Shah from Rochester Institute of Technology, USA. I welcome you, and I'll hand over the session to the session chair. You can go ahead, Dr. Hardik.
Thank you so much. Hopefully,
yeah.
Okay, thank you.
Yeah, Dr. Hardik, your volume is very less.
Yeah, how about now? Today, am I audible?
Yeah, now it's fine. Yep, it's good. So you can start your session, Dr. Hardik.
Yes. Hello, good morning to everybody in London time and wherever you are. We are on the second day of West 2023. And we will start the session with a topic in the computer networks and data communication track. Topic name is Unraveling DNS Performance, a historical examination of F-root in Southeast Asia. This topic has two presenters, Jia Zhu and Kao Chi. I apologize if I'm not saying it correctly, but both the presenters are from China Academy of Information and Communications Technology from Beijing, China. Shah Zhu is a data analyst in CAICT, skilled in data analysis and ICT-related field. Kao Shi, an engineer of R&D and maintenance in CAICT, is skilled in DNS, industrial, IoT, and blockchain. Welcome both the presenters. You are free to take over the screen share, and you will have 28 minutes, and then we will follow it up with any Q&A.
Hello, I'm Zhu Jiajia from, can you see the screen?
Yes.
Okay, so I will go on. I'm Zhu Jiajia from China Academy of Information and Communications Technology. My co-author is Qi Chao. Our research name is Unrevealing DNS Performance, a historical examination of F-root in Southeast Asia. First, I want to briefly introduce some basic knowledge about DNS. As shown on the left, the picture shows the conventional process of DNS query resolution. Thanks to the cache of the recursive server, most domain name query requests can now be responded to through the cache. But if there is no cache, the recursive server needs to query the authoritative name servers level by level. And the starting point of this process is the root server. So its resiliency is very critical. And so this is the root server. Presently, there are 12 ICANN authorized root operators responsible for managing a total of 13 root name servers, denoted from A root to M root. To be able to respond to a vast and continuous stream of questions, now it has passed 80 billion per day, as well as to resist various cyber attacks. The root server operators have met this resiliency requirement by distributing root server instances around the world using a routing technology called Anycast. Anycast routing allows Machines over the internet to use the same IP addresses to provide identical responses, thereby allowing root server instances to be located in hundreds and different cities and countries. As of mid-August, there are more than 17,000 instances, which we call root nodes in this research, deployed in 169 countries. Among A2M root, F root nodes had surged from 58 in early 26 to 505 in August 2023, marking a nearly tenfold increase. And among all continents, Asia leads the way with the number of F root nodes growing from 15 in early 26 to 191 as of August 2023. So our research centers is focused on the F root and select Southeast Asia as the primary research area. So here are some questions that we expected to explore through this research. First, how query latency changes with the number of F root in Southeast Asia, ICA region, and individual countries. 2, does more F root guarantee lower latency? 3, does more root servers contribute to higher domestic resolution rate? 4, should more F root be deployed in ICA region or in any particular ICA country? Next, I will briefly describe how this study was conducted. Data we used in this study is sourced from Web Atlas platform. It is a global probe network designed for testing network connectivity and reachability. Currently, it has more than 12,000 of active probes distributed worldwide, and the number continues to grow. Among all ICA countries, we selected those that had more than 1 active probe in early 26 and has at least 10 active probes in August 2023. And meeting these criteria are only 6 countries, which include Indonesia, Malaysia, Philippines, Singapore, Thailand, and Vietnam. DNS measurements are built-in measurements of the web platform, and all data are publicly accessible. In this study, we collected DNS records from all probes in the 6 countries mentioned, sampled at regular time intervals from January 2016 to August 2023. In addition to RAPS data, we also utilized the historical archive data from the rootserver.org platform regarding the deployment of root servers, such as types and geographical locations of root nodes. After collecting all the data, we employed a relatively simple and straightforward method to identify and locate the responding root server. Put it simply, first we obtained the hostname of responding root nodes from the RAPS measurement records. And then we used the hostname to match it with the identifier field in an archive YML or JSON data from the rootserver.org website. If the match is successful, it automatically identifies and locates the specific responding root node. So now we have everything, and it's time to do the research. In the first section, we analyzed the use of F root in ICN region, focusing on the number of nodes and query latencies. In this chart, the black line signifies the number of F root, while the red line represents the average RTT, which is a written scattered data points are visible in blue, where each point signifies the average RTT of an individual probe. Darker color indicate a higher concentration of similar RTT result. Generally, a denser distribution along the x-axis indicates better performance. At 2016, there were a few F root nodes deployed in ICA region. Before May 2017, some data points clustered at the upper part along the y-axis, mainly centered at 200 milliseconds and 300 milliseconds. In May 2017, 6 new F root added, leading to a noticeable change in distribution of data points. Near the x-axis, the color became darker, indicating a significant decrease in RTT. Over time, beyond 2020, the width of the distribution at the lower position gradually narrowed compared to the previous periods. However, with the number of F-root nodes continued to increase after 2020, there was no apparent change in the distribution of the scatter points. In the next section, we analyzed the historical changes in query latency and the number of F-roots in 6 different selected countries. Observing each country individually, we can find, for Indonesia, the number of F-roots increased from 1 to 7. As the number of F-root nodes increased from the trend of the right line, it can be seen that the average latency has decreased, but it is not so evident. For Philippines, before 2017, the Philippines had no domestic F-root, resulting in a broad distribution of query latencies. It adds its first F-node in April 2017. We can see a significant improvement manifested as a gradual decrease in points at higher position and an increase in points closer to the x-axis. But after 2021, the subsequent increase in the number of routes didn't bring continued performance improvement. For Thailand, initially the absence of F-root resulted in broad latency distribution. In May 2017, Thailand introduced 2 F-root, which improved the situation. Points in the upper layer started to decrease. By December 2017, the number of F-root increased to 6, and we observed a continued decrease in points in upper layer. Meanwhile, points in the lower layer started to settle even lower. During the first quarter of 2018, points in the upper layer gradually decreased to near disappearance, and the points in the lower layer sunk to the very bottom. Afterward, the F-root kept increasing, but latency didn't show significant improvement. The trend in the other 3 countries are basically similar, with the exception of Indonesia, who has already achieved good performance even at the start of 2016. A common pattern emerged for all other 5 countries, and it leads to the same conclusion as in the previous section, which is early introductions of root nodes consistently produced substantial improvement in latency, while later introductions had a more limited impact. In this third section, we examined the historical trends in the distribution of destination countries or regions, with each row representing a selected country and numerical labels at the top denoting the years, and the bottom number 1 to 4 indicating the quarter of a year. Different colors representing the countries or the regions where responding root nodes are situated. To enhance clarity, we merge destination countries or regions with proportions below 1% into a single category labeled as others. And additionally, some responding root nodes couldn't be identified or located were collectively characterized as unknown in this study. From the graph, we can see that Singapore's F-root, in this color, Singapore's F-root is widely accessed. Apart from Singapore itself, queries from other 5 countries also access Singapore's F-root during different periods, some with relatively high proportions. Malaysia's F-root has also been accessed by other countries, particularly from 2016 to the third quarter of 2018, when it was among Thailand's top 3 destination countries for F-root. In addition, Indonesia and Thailand's F-root were briefly accessed by probes from outside their respective countries, but the proportions were so low that they appear indistinguishable in this graph. In contrast, Philippines and Vietnam's only have local type of F-root, and their F-roots are only accessible to probes within their own countries throughout the entire time span. And besides, we can see that in the early stages, notably in 2016 and 2017, except for Indonesia and Malaysia, the other 4 countries had a significant proportion of their F-route queries routing to US and the Netherlands. And after 2023, none of the 6 countries had its F-route queries routed to route nodes located outside of Asia anymore. The primary destination for F-route in each country is now their own country, with domestic rates exceeding 90% for Indonesia, Malaysia, and Singapore and Thailand. But for Philippines and the Vietnam, these rates are lower at 63% and 46%. We speculate that this may be related to the adjustment of their teleoperators' routing policy. Besides their own country, these 2 countries primarily access the F routes in Hong Kong and Singapore. More nodes didn't bring higher domestic rates for these 2 countries. It may be intuitive to think that introducing more F-route nodes would increase the proportion of responses from domestic route nodes. However, our findings reveal that as countries introduced more F-route, the proportion of responses from domestic routes didn't consistently increase. Instead, it fluctuated. Though the root cause of this phenomenon is not clear yet, we still think that countries may not necessarily need so many F-routes. So in the first part, we focused on the data extracted from July to August of 2023 and plotted the most recent cumulative distribution function curves of RTT for each country. We can see that all countries have a proportion of RTT under 50 milliseconds, exceeding 90%. However, a closer examination of the proportion of RTT under 25 milliseconds, and this line, it reveals gaps among countries. Indonesia, Malaysia, Singapore, and Thailand constantly maintain proportions above 90%. In contrast, Philippines and Vietnam, while achieving good average RTTs, they exhibit room for improvement in reducing RTT variations, with proportions under 25 milliseconds at 79% and 53% respectively. So finally, there are the conclusions we reached through this research. First is regional improvement. The introduction of F-route nodes has positively impacted the region, while the most significant improvement occurring in the early period, especially in 2017 to 2018. To geographical distribution. As F-route nodes increased, each country ended up with querying more of their own route. Presently, Indonesia, Malaysia, Singapore, and Thailand have domestic resolution rates exceeding 90%, while Vietnam and the Philippines lagged with domestic rates of 63 and 46 respectively. RTT CDF characteristics, over 90% of queries had latency value between 50 milliseconds for all countries. However, Philippines and Vietnam exhibited significant lags when it comes to percentage of smaller latency values, like under 25 milliseconds. Philippines and Vietnam can still work to reduce their latency variances. So, given all the findings, it's our view that adding more F-route to these countries appears unnecessary, and we advocate for exploring alternative strategies such as implementing a local copy of the route zone file or optimizing the route strategy are worth considering for further optimization of the DNS infrastructure of the ASEAN region. So that's the end of my presentation. Thanks for your attention.
thank you so much to Jaja Zhu and Kao Chi for your enlightening presentation on unraveling DNS performance, a historical examination of F-root in Southeast Asia. We are opening to our audience for any questions you may have. Yeah, you may please unmute yourself if you want to ask any questions. And if not, we have 11 minutes before we start our second topic. Thank you.
Thank you.
Right. Hello. Under the artificial intelligence, soft computing and applications track, we have our next topic, which is the second in the line. It's Welcome to Ultaki, exploring the relevance of large language models for accurate behavioral simulation and energy transition. The speakers are Mehdi Monsif, Benjamin Jovian, and Fabien Medard from Acodis Research, France. Hello,
Hello, everyone.
professors. Please go
Yep.
ahead. Thank you.
Thank you for inviting Dr. Hardik Shah. Since the authors are not here, I would like to play their video presentation. Give me a minute. I will share the presentation video.
Greeting everyone from every time zone. Today, it is my pleasure
Can you hear me? Can you hear the video's presentation audio?
Yeah, we can hear the audio.
Thank you.
to introduce you to our most recent project that is called Welcome to Ultaki, harnessing large language model for simulating human behavior in the energy transition. Let me kick things off with a brief overview. We are currently grappling with some significant climate-related challenges. Specifically, they are centered around the imperative shift to clean energy. But in this scope, there are multiple issues to contend with. Primarily, the ever-rising demand for energy is a challenging scenario, in particular when coupled with the susceptibility to extreme weather conditions. Despite our best efforts to reduce carbon emissions, the current pace is not commensurate with the best commitments of the Paris Agreement. And as such, the energy transition, it requires significant and substantial financial investment, further complicating matters. Lastly, a key complexity that we cannot afford to underestimate is the unpredictable and non-linear nature of human behavior, which significantly impacts the transition and is actually one of its main drivers. A key aspect in this energy transition is the concept of smart grid. Essentially, a smart grid is a flexible, adaptable system architecture that is designed to integrate seamlessly with renewable energy. That's very interesting, and the primary objective of this integration is to optimize power distribution and enhance the overall sustainability of the system we are considering right now. However, transitioning to smart grid also brings a series of challenges. Indeed, one of the main concerns with renewable energy in the context of smart grid is the issue of intermittency. That is, we have to deal with the unpredictability of renewable as a consistent and controllable energy source. That contrasts strongly with current fossil fuels main energy sources. And in this scope, this necessitates careful regulation of supply and demand to ensure balance at all times. Furthermore, we have also the fact that smart grids are networks and they may introduce some vulnerability that can pose additional challenges. All of this context emphasizes the need for accurate behavior modeling, because given all of these factors, we need to be able to correctly dimension and predict the energy demand that will happen, so that we are able to anticipate any unforeseen and undesirable effects. Overall, what it means is that the reaction of consumers to this condition and the consequently triggered fluctuation in the energy demand can significantly impact the overall operation of the smart grid system. In this scope, what we propose is to use large language model to explore and try to accurately model the human behavior, which, as I mentioned, is of the utmost importance in the scope of the energy transition. Behavior modeling is of pivotal importance, both in the energy transition, but also abroad. And as such, it is a topic of immense importance that has been largely explored, and there is a significant body of work that accompanies this field. Among the most notable approaches in this body of work are the conventionally modeled approaches, such as using cellular automata system or differential equations. In this scope, what we try to do is to identify the key environmental interactions and subsequently model their drivers and comprehend how different variables of the system or within the population respond to some of the system shifts. More recently, and maybe more focused and targeted on human behavior, the significant shift toward more advanced and complex method has enabled us to use social computing within human community studies. Specifically, what it means is that we, through the availability of social network like Facebook or Twitter, now X, there has been an abundance of data that has also influenced the field in how modeling of human behavior can be approached. Even more recently, recent progress in natural language processing and the emergence of large language models have underscored their capacity to make significant contribution in the realm of human behavior. In particular, their remarkable generalization abilities can be harnessed through prompting, and as such, we can construct alternate strategies to understand to deepen our understanding of human behavior and enhance our social simulations. In particular, we can cite and refer to the significant and pivotal work from Park in 2023 that introduced Smallville, a city that is only populated with large language models with different background stories, and we were able to witness plausible and emergent behaviors that suggest that indeed large language model can play an interesting role in human modeling and exploration of the influence of human behavior on various systems. In their work, they refer to specific components that made their progress possible. For instance, the fact that they use memories can enable agents to devise plans, and specifically our own methodologies that we underline and we present in this work operate on the hypothesis that this framework can be extended to cater the field of energy policies. In this scope, our work primarily focuses on the innovative use of the large language model technology to mimic personas from diverse scope and diverse background. Concretely, we refer to the 2016 US election demographic profiles to design and imagine a set of characters. Specifically, this involves using the Pew Research Center to construct a variety of characters, each of them with their unique life stories and backgrounds. In this scope, the goal is to determine how these personalities, and each representing an assortment of societal profiles, would potentially react to diverse events. This allows us to gauge not only the legitimacy of their response, but also to identify the distinctiveness of each person's reaction. To do so, beyond utilizing the research center demographics for simulating human, we also factor in several events to engage with these agents. Specifically, these events vary in terms of relevance, ranging from personal banter to environmental and energy-related discussions. Some examples of these events are personal conversation, similar to the casual discussion one might have with a hairdresser, Others are related to more localized terms, such as a local radio shows discussing recent happening or hosting guest interviews. And finally, we also represent the global context by including newspaper editorial or significant news events. Our intent behind presenting these very diverse events is to examine how these discussions influence the agent's viewpoint and environmental sensitivity. For instance, a light-hearted, personal conversation wouldn't necessarily alter the agent's perspective significantly, especially if unrelated to energy topics. However, conversely, a discussion centered around politically charged or contentious topic may call for a response from the agent. And as such, having established the need for diversified agent, let's now transition to the next segment, which pertains to the experiment we designed. Our experiment endeavors to analyze various facets of the large language model in their simulation of human behavior. And in this scope, our primary goals are as follows. We want to assess the plausibility of the response generated by these models. We want to evaluate the extent to which the presented prompts influence the generated responses. And finally, we want also to examine the role and impact of higher order dynamics, which in our case means to implicitly include memories within the models, within the prompts and the models. Diving right into our first experiment, we investigated the individual's reaction to sequential series of events simulated by the large language model. In this experiment, a group of virtual agents went through the same course of 10 predefined events. And there we meticulously tracked their response and ratings over time to observe the diversity and unique path they embodied as to their environmental sensitivity. If we glance at the figure, it becomes apparent that the response pattern exhibited substantial differences among the studied agents. Every agent had a unique start and endpoint. However, we still identified some shared trends among the agents with a similar demographic identifier. For instance, in this particular figure, agents representing Democrat exhibited a close-knit response pattern. Likewise, we observed overlapping pattern among agents depicting evangelical Republican or libertarian anarchists. These variants suggest a significant influence of the background settings and narratives on the agent within the program sequence of events. Our next experiment focuses on who makes the environmental sensitivity evaluation. That is, we assessed the performance of an agent designed to mimic human behavior in a specific scenario. And from there, the agent functions by evaluating its own environmental sensitivity score and consequently adjusting its environmental sensitivity. This allows us to observe how effectively it adapts and whether its environmental awareness increases or decreases over time. And the interesting thing here is that this evaluation process can be performed in two ways. Either it is a self-evaluation, so the agent rates itself, or it can be externally judged by a third-party observer, that is another agent that is prompted differently. In this experiment, we compare these two assessment methods and we notice some distinct differences, though they are not extensive. The thing is that the resulting scores varied based on who conducted the evaluation, whether the agent itself or the external entity. And that's intriguing to observe because I think it would be worthwhile to further investigate and quantify the severity of these divergences, because it can definitely have an impact on the trust that is given to these methods. Then, as previously discussed, we considered experiments based on the way we prompted the agent. As you, I'm sure, are well aware, the method of prompting an AI agent is critically influenced on both the evaluation of the agent and their comprehension of the given situation. This concept aligns with our central theme, that is, and what I mentioned earlier, that is, the mere alteration of a few words in the prompt should not skew excessively the outcome. Because if so, we can raise legitimate trust issues. So this concern also has significant influences regarding the incorporation of second-order dynamics. As I mentioned also earlier, simulation of complex model and population dynamics involves having agent react in single-step manners. So that happens a lot in, for instance, cellular automata, or when you design a system through differential equation. When you want to encompass second-order dynamics, you have a steep increase in the complexity of the system, and thus it's not trivial to do. And in this scope, in our study, we wanted to explore the effect of these second-order dynamics through enhancing the agent context prompt with its memory. So with the previous steps it went through, this implicitly simulates higher order dynamics because we have a memory of what happened before. And so it's easier to enrich the prompt of the agent than to come up with a similar approach in a differential equation, which is way more arduous. And as you can see, we have when we observe the agent reaction to past experience, we confirm that having access to memory enhances environmental sensitivity. However, because of the technical scope, there are some nuances that cannot be understated. Because, for instance, the way we would structure the prompt, for instance, if we had the background story of the character background story at the top, maybe if we have too many memories in between, we may lose and overshadow the psychological traits of the agent. So there is a whole scope of system design that cannot be understated or ignored in this scope. Finally, we considered and investigated a multi-agent scenario. Specifically, what we wanted was to move on from the independent and siloed operation that we had before, and consider that each agent's actions will have a wider and global change. Specifically, we look at a simplified configuration where all of the agents we previously defined and that were evaluated coexist in a city. They may represent a larger collective, but they are all residue of this well-defined environment. In this scope, they share a residency, and each agent's actions and sensitivity have ripple effects, as I mentioned, that can also have an impact and influence on other agents. The mechanism we chose to represent this impact is a predefined threshold. When an agent's environmental sensitivity moves, it moves the global environmental sensitivity score, so the average of all scores, up or down. And whenever this environmental sensitivity average crosses a threshold, it triggers what we term a traumatic event. For instance, those can be blackouts or, for instance, also increased energy prices. The crux of our experiment is to ascertain if these agents, when exposed to the traumatic event, modify their behavior. And in this scenario, every agent lives in the same city and experiences unique events, so they do not share the events like they were before. But when the traumatic events happen, they all receive a trigger, so they all share the same traumatic event, and we compare different trajectories in which the agent have access to these traumatic events or not. And as you can see on the figure, we observe a distinct trajectory, global trajectories and individual trajectories when the traumatic event is present, which means that there is some legitimacy in envisioning multi-agent systems with events that concern everyone, or as also suggested by Park in their study. In conclusion, we delved into how large language models can simulate human behavior, particularly in the realm of energy transition and energy management. Indeed, this study was illuminating, and it has given us hope and motivation to further push this approach. One of the main reasons is that this approach holds tremendous potential for impacting and revolutionizing maybe various domains in the industry. It has the capacity to shape a lot of things, including energy transition and going up to societal resilience. However, this is also a preliminary work because we can't really lose sight of the limitations. Our research indicated a striking sensitivity to prompting, and that may be also that may be related to the fact that we use GPT 3.5, but that because we did this work a few months back. So maybe with improved model and potentially fine-tuned model that would be fine-tuned maybe on specific data, we might be able to offer a more robust and faithful representation of behavior and less sensitivity to prompting. Finally, we were also successful in eliciting a myriad of diverse opinions, demonstrating that large-scale language models have the capacity to capture the intricate nature of human behavior. But as the saying goes, every coin has two sides. Since also, as I mentioned, we were using OpenAI's model, we likely encountered bias because of the stage of reinforcement learning through human feedback fine-tuning. In this fine-tuning stage, controversial topics such as climate transition or having dangerous thoughts or generating text that is not desirable is discouraged through the use of reinforcement learning and a penalizing reward. And in this scope, this may lead to complicate. It's harder to be able to simulate individuals that do have and do share these views. I mean, it would be possible to jailbreak or maybe find a way to prompt the model back to ensure that it is able to simulate this kind of person, but that would have maybe ripple effect on the experiment itself, because the prompt would be different from the other models. Anyway, just as it brings promised enhancement, this approach also brings with it complex challenges which require addressing. So we have only just begun to delve into this consideration. Nevertheless, I hope you enjoyed this talk, and I'd like to express my sincere gratitude for the board's comprehension as to me sending a video. Thank you very much for your attentive participation, and I hope you have a great conference. Thank you very much.
Thank you very much for listening. Since the authors are not here, I can't take up the questions. If you have any queries, feel free to send it to the author's email ID. Again, thank you very much for listening. And back to you, Dr. Hardik Shah.
Yeah, sure. Thank you. Thank you, presenters, for the insightful presentation. We have 6 more minutes, and then we will move on to the next topic, the third topic. Thank you. All right. We will move on to the next topic, which is going to be the third in the series. This is under the track of artificial intelligence, soft computing, and applications. The topic is axiomatic methodology of formalization as a way to intellectual analysis and computer science. And the presenters are Victoria Kondratenko and Leonid Slovianov. Both are from School of Informatics, University of Edinburgh, UK, and Leonid is from Center of Innovative Medical Technologies of the National Academy of Sciences of Ukraine. Welcome, presenters. Speaking about the introduction, Victoria is a mathematician with a specialization in artificial intelligence and PhD. Also a physician and specialty is neurology. Leonid is an IT specialist, a medical statistician, and an engineer with experience in medical technology, science, and engineering. You welcome, speakers. You feel free to take over. Thank you. Hey, Victoria, was I audible? Hey, Victoria, are you still connected with us? We see your slide deck, but there's no audio.
One moment. It's okay?
Okay. Yeah, we can hear you now. Thank you.
Okay. I would like to share with you our vision of prospects for creating an universal mathematical formalization algorithm for the intelligence analysis of the information result of solving intellectual problems, that is, problems that have no solution in the moment. Axiomatic methodology was created. Semantic analysis is the most urgent problem in the science of artificial intelligence today. The way to solve this problem is systematization and formalization of existing knowledge, definition and methodology and goal of cognition, the surrounding world. In their formal procedures on proving statements. We are only at the very beginning of this path, and the success of the search on universal algorithm will depend on how strictly we follow it. We could explore all three directions more actively, and we have started moving along this path. Research into the nature of human thinking is very active today. Varying what they tell us, if their report is important not only for doctors and biologists. We tried to investigate how human thinking works and came to the conclusion that hypothetical statements are unacceptable in science. This actually true mathematics. Statistics studying the possibilities on the human psyche, we came to the conclusion that it is necessary to verify the truth of the conclusion. It's every step of proving the truth of statements. This, in the end, helped to create an effective algorithm for solving intellectual problems and formalization methodology. But the purpose in this presentation is not to advocate the method being developed, but to remove obstacles for further effective work. Classical mathematics is product the human psyche. The most important feature of the high mental function thinking is the template interpretation of the function opening with meaning. When solving problems or analysis of dynamic system. Formal languages of classical mathematics call it mathematical structure model thinking process in some way. Every mathematical structure, even the structure of classical mathematics, such as integration, must be described. Its performance and action are important for describing the classes of tags, the area of knowledge in which.
Sorry for the interruption, Dr. Victoria. Your slides are not moving.
Slide не движется.
Yeah, also your audio. Yeah, if you can be a bit
It's
louder.
Okay, no.
No, you're still on your first slide. So while you were speaking, you were not navigating the slides. And if you can just be a bit louder for our audience.
Now it's okay, no?
No, and your PowerPoint slide deck is still on your first slide. Your PowerPoint, your Microsoft PowerPoint.
Yes.
It's still showing the first slide.
Only first slide?
No, yeah, it's the focus is on the first slide. You know, while you were speaking the content, you were not navigating the slides.
And now work or not?
No. It's still the focus is on the first slide.
Only first slide. We don't know why.
Can you share again?
Yes. Share. We'll try.
Yeah.
But now
it's now we can see the fifth slide now.
Okay.
Thank you.
Okay.
Так, языка. Так, formattation language. Yeah. Maybe I repeat. Yeah. Every mathematical structure, even the structure of classical mathematics, such as integration, must be described. It's sorry. Okay. Yeah. For the purpose of anniversary, in our opinion, the mathematical structure of first-order logic is most suitable. It was shown by us for the purpose of solving intellectual problems and described in detail and methodology on solving intellectual problems. But today, the researchers is very actively using on mathematical structure. They are used in all spheres as your activity. In fact, without having their description both on term of affection for particular type on problem task, and the cost researcher actually on the solution and so on. For each of the more than 1,100 mathematical structure, we do not have passports that will tell us about on effectiveness of choosing a method for solving a particular active problem. And this is exactly the problem that I would like to talk about today. After all, the choose on the method on solving a problem, then currently created psych or mathematical model and practical problem can radically reduced of increase the time and resources and the solving a particular practical problem. This is much more than replacing one method with another and more effective one. And currently created model focuses on the attention, on the goal, on solving the problem, strict and understanding the nature and the phenomenon on the depot of the meaning the problem. Actively in the understanding space or has convinced us on the need to correct not only on common view, depending on the emergency of new knowledge about our own physiology. It is also necessary to improve on the tools for achieving the goal of condition in the process, obtaining the new knowledge about oneself and nature as a whole. I'm talking about mathematical and physiology now, first of all. I can't help but say about AI scientists and about science of the brain. Each of the science was unitarily accident an important role. Our task today is recall their role and put together a puzzle or mosaic of AI science. Think into account each science depending this place in the general coordination system. As an example, philosophy. And each state of the development of the whole goal on science, it's possible the summary their own result affecting them and philosophy categories. In the science for artificial intelligence, knowledge about function on the brain must necessarily be present. This knowledge can help to improve the formal scientific content generated by the psych. It is also necessary to determine fundamental innovation for evaluating for our activity in order to check an advancing to modeling the process. Thank you for attention to my English. I would great it you send your question to my email, please. Thank you.
Right, thank you so much, presenters, for this enlightenment presentation on this topic. Anybody, any questions? If not, in just a minute, in 30 seconds, we'll move on to the next topic. Right, so no questions. Thank you so much, presenters. We will move on to the next topic. So this topic is under the
Yeah,
chat
Dr.
website.
Hardik, I think the next presenter is here.
Is myself.
Yeah, I'll just invite you for the presentation. So I welcome Dr. Hardik Shah from Rochester Institute of Technology, USA, entitled on Advancing Web Accessibility, a guide to transitioning design systems from WCAG 2.0 to WCAG 2.1. Yes, Dr. Harsha, you can go ahead.
Yes, thank you. Just a second.
Yeah.
Right, hopefully, good morning, guys. Hopefully my slide deck is visible.
Yep, it's
yeah,
visible, and you can go ahead, Dr. Hardik.
Yeah, thank you so much. Here, what we have is, what I'm covering is a combination of three things: what W3C is, what WAI is, and what the user, user pertains to what. So essentially, W3C is called World Wide Web Consortium. It's a global body, a consortium, which makes and maintains these guidelines, and it maintains the guidelines on web, it maintains the guidelines on web accessibility and several other topics. Under W3C, we have as a WAI, Web Accessibility Initiative. WAI is a body inside below W3C, which takes care, it's a group which takes care of the accessibility guidelines. And speaking regarding our accessibility fundamentals, we basically speak about the audience, which are people with disabilities. Now these individuals of the audience may have partial disability, or they may be colorblind, or they may be partially blind, and so we are speaking with respect to that audience. Also, accessibility, it just does not pertain to just basically those audience, but even older users, and just improving the usability, even for those which are not impaired. Now, we have certain principles when adding accessibility. We target certain principles. There are 4 principles that we target under WCAG 2.0 and 2.1. The first of the principles is perceivable, ensuring that the information user interface is perceivable. Second one being the user interface and navigation being operable. Third one, the information user interface being understandable. And the fourth one, the content and reliable interpretation being robust. Now, these are the 4 core principles, and we have certain sub-principles beneath that, ensuring under perceivable, when you look at a particular user interface, even this web page that you see right now, it's, under this principle, there are the guidelines suggest that there should be text alternatives for non-text information. So non-text information pertains to certain images. There should be captions and other alternatives for media. So for example, something like a video, and if you want to make a video accessible, ensuring that there are captions, just like YouTube has, that's one example. And there are several other such principles that we have. And so that speaks to what W3C does, how what WAI does, and the accessibility principles underneath them. Now, moving on to the second part, which is speaking about WCAG 2.0. Now, WCAG 2.0 came in 2008, and it's basically the second, previously we had, it basically is a section, there was previous guidelines called as section 508, and it's augmentation of section 508. And in section, as you can see, section WCAG 2.0 was released in 11th December 2008. And these are the official guidelines published. Now the guidelines, there are 2 types. One is a normative, and then the other one is descriptive. The normative guidelines are basically meant to be published, they are published as a norms or as rules, just strictly as rules, and under these, as I said, there are principles, there are guidelines, and there are success criteria. Now, these success criteria are basically pertain to certain rules, what should be applied. And then we have a fidelity or a level of conformance. And there are 3 levels of conformance: A, AA, and AAA. The AA are the ideal guidelines that you typically aim for an ideal scenario for a particular device, environment, and a particular medium, and say a user. AAA is the strictest, the highest form of conformance that you will add. And there are basically, there are success criteria, as I mentioned, actually, under every guideline. As you can see, basically, we have under this principle, we have the non-text content, and under that, we have certain success criteria. So that basically, hopefully, that breaks down how these WCAG guidelines flow. Now coming back into the we spoke about how this basically W3C, builds these guidelines through these bodies. We covered accessibility fundamentals. We covered WCAG 2.0. Now, the successor to WCAG 2.0 is the WCAG 2.1 guidelines, which is the topic right now. And the strategic incorporation of WCAG 2.1 into design systems, presents a significant advantage. What a design system means is something I will cover shortly. WCAG 2.1 extends beyond the provision of WCAG 2.0 by addressing a wider range of disabilities. Now, speaking in respect to design systems, so speaking of design systems, when you're looking at a particular web page, say facebook.com or say youtube.com, Gmail, you will see certain elements of user interfaces. These elements of, you may see a search box, you may see a navigation on the left side, or on the top, you will see hyperlinks, you will see several elements. Now, these pertain to different elements of user interface. Design system is basically a superset. It's a collection of UI components and several style guide that represent a cohesive set of principles. patterns and practices that guide the design and development process. It also represents a fundamental framework and provides a structured approach to creating and managing, a user interface. The importance of a design system also lies in the ability to ensure consistency, improve efficiency, and foster collaboration amongst development teams, ultimately leading to a more cohesive user experience across various digital platforms. The strategic incorporation of the WCAG 2.1 guideline, which we will cover shortly, into design system, presents a significant advantage. But before we go there, we'll break down design systems and understand design systems in depth. So here is basically a structural breakdown of a design system. As I spoke, there are building blocks, or called the foundations of a design system, even before you see the elements. Now, some things are editorial guidelines. How would you want the branding or the color, the color guidelines to be? A good example is for, say, something something like a social media website like Facebook. You will see the dominant colors are blue and white. And for something like YouTube, you will see it's basically red, black, and white. These are color schemes. And these are color schemes are based on a particular, branding, and, they are meant to be overridden and, be consistent across the entire application. Then there are grid definitions, these elements are laid out vertically and horizontally, and we have a grid structure for every application which determine that, and that's part of a foundation. Then there is iconography, there are image assets. And then there are UI patterns, we have these components. So for example, a text box, a drop down, or a combo box, which will show you multiple list items. There may be an accordion, which will have an expand and collapse for information. There may be radio buttons. These are all part of the components. And then these components could be bundled as inside a module. These modules could be bundled inside these templates. So the information will flow like as fields, which are part of component library. Component library could be part of a module, and this module could be part of templates. Now, templates could be something like a details template, a search results template. Similarly, we have we have an overlying actually rule sets for design principles, and all these do's and don'ts and several FAQs, everything which becomes part of a design system. Now, another perspective of a design system is like a biology, or as an organism, at a very granular level. At the lowest level, they consist of atoms, molecules, which make up these organisms. So that's what basically a system is. And this pertains, similarly, that's what a design system equivalent looks like. And when you look at a product, say a web application, whether you're building your own or an existing application, say Amazon, anything, they're made of these templates, the templates which consume this design system and the components in it. And the pages that you see, whether it's the home page, or say when you're shopping through an e-commerce website, you reach out the checkout page. There are multiple pages when we use these templates, to build up a user experience. Now, just one example for our audience. We will go through, we will show basically one. So we will basically review one design system, which is BBC's design system. Here is BBC's design system. As I spoke, for the example that I gave over here, it consists of several guidelines, design pattern, foundation. Under foundations, it speaks to the grid structure, several design principles, typography, the kind of fonts and the colors and everything. And the design patterns pertains to the component library. One example is an accordion. Then we have cards, carousel. Carousel pertains to, an image, a slider. So it has basically the specification and everything for it, along with different variations actually of the slider. And so that's one example. Similarly, we have Microsoft's Fluent design system. Salesforce has its own Lightning design systems, which are the most popular one. Now, speaking in respect, us going back to our presentation, this We covered the WCAG and W3C and how it provides these guidelines for a structured approach. And it's also become essential for government to provide. It's also important basically become for the government to provide, add these guidelines to their websites for compliance. So they're code with equitable access, inclusion, and it basically, it's also the government's agencies to provide legal responsibility to serve all residents, and which include the impaired users as well. Now, WCAG 2.1 significantly improves web accessibility requirements, but it's built on the foundation of WCAG 2.0. A critical component of the new criteria is that they address the changing landscape of digital interactions with a particular emphasis on mobile accessibility. The new criteria emphasizes developing a more cognitive, accessible digital world, lowering possible barriers for people with various cognitive abilities. Now, we did a literature review before I did the research to basically ensure what's out there. And there are several parts actually that has been covered, but there is a unique merit to my research, which we will go through. As part of the literature review, we looked at, there are certain research which basically has covered, understood what WCAG 2.0 is and its limitations is. There's also research out there which speaks to the emergence of WCAG 2.1. And there are certain transition challenges when migrating from 2.0 to 2.1 for web developers and designers. There are studies based on that. There are also some studies which reveal the lack of preparedness in this industry for this transition, suggesting a need for comprehensive guidelines and tools for aid in the process. Now, there are also certain researchers which have independently developed tools as part of the research study and frameworks to assist in this transition. There's also a design framework created which integrates WCAG 2.1 principles into the design process, making accessibility a foundational components of web development and not an afterthought. And there are case studies and best practices. There are also future directions in web accessibility, which has been studies. Now, the unique or the distinct merit of this study paper is that it does a thorough study and consolidates all the learnings actually from my professional and from my academic side to build a guide for migrating a design system into WCAG 2.1. And as I said, the specific emphasis is on a design system while aligning with the larger objective of a universally inclusive digital world. By embedding WCAG 2.1 into design systems, organizations can ensure compliance with legal requirements across a large suite of their applications. Now, in this part, we are gonna dive into WCAG, understanding WCAG 2.1 in depth. As I said, WCAG 2.1 is built on the foundation of WCAG 2.1. It's an upgrade on 2.0, and it adds 17 new success criteria. And again, it has 3 levels of conformance: A, AA, and AAA. It enhances the inclusivity and the usability of digital content, including websites and web applications for individuals with various disabilities, including visual, auditory, motor, and cognitive challenges. There is also a legal mandate for United States for its government departments and their sites that they should be WCAG 2.0, at least at a minimum, they should be compliant. And now there's a legal mandate coming for a lot of enterprises. It's already out there for a large e-commerce, the top 10 Fortune 10 companies, Fortune 50 companies. And there's a mandate for government website compliance so that they can accord with equitable access, inclusion, and government agencies. So this basically breaks down, understanding WCAG 2.1 compared to 2.0. 2.0, as I said, has 25 success criterias. And WCAG 2.1, WCAG 2.0, like I said, is based on Section 508, which was a precursor to it before WCAG came along. WCAG 2.1 was rolled out in 2018, and it basically came out with 17 new success criteria. And specifically, if you are basically dealing with AA level of conformance, because you got to pick And ideally, most of the organizations choose AA, which deals with the biggest and most common barriers with users with disabilities. That adds 7 new success criteria. So when you combine, let's say if you are basically if you are not WCAG 2.0 compliant, then you are looking at an addition of 13 success criteria for WCAG 2.0, 7 for 2.1, that makes it 20. Yeah, so we will understand through, now we will look at the official specification for WCAG 2.1 before we dive into the migration. This is the official specification, and we have 4 principles under which we have principles related to orientation. WCAG 2.1 specifically in terms of adaptable guidelines suggests that whether you're looking at a website, whether and it should be responsive, meaning that the device orientation, whether it's in a portrait mode or a landscape mode, should be adaptable. Whether you're looking at a website on your mobile phone or your tablet, iPad, or any other tablets, it should adapt. There is also guideline related to reflows, that the text and everything should reflow in such a way that they adapt, while at the same time ensuring that it's accessible with the keyboard, also ensuring that status message are visible. There's also related to text spacing, zoom levels, ensuring that if you are zooming your screens by 400%, it does not, any content in the screen does not escape the viewport, and everything is visible within the viewport being the bounds actually of the browser. And there is no horizontal scroll bar basically introduced in such a way that you have to scroll to look at more information. So that's another example of a guideline. Now we can look at, it's very, while looking at this and trying to interpret this, it's important, like I said, that to understand that every guideline that are WCAG is published in 2 guidelines. One is the normative and other is the descriptive. The normative guideline speaks to the success criteria and the description of the guideline, but the descriptive guideline describes it even further with examples and breaks down precisely what they interpret in terms of what does that guideline mean in terms of web UI engineering. Now we will also look at a particular map. This map, it's easy to get lost into this guideline and everything. So this is a map by by Intopia, and that summarizes everything. How do we understand WCAG 2.1? So this map speaks to basically these 4 principles and the guidelines beneath that. So for WCAG AA, 2.1 AA, it speaks to the captions that should be there for a video or any media. There should be audio description. The orientation, as I spoke, whether you're looking actually in a portrait mode, landscape mode on your mobile, it speaks to that. Now, there are certain benefits having basically understood these guidelines. There are several benefits. This research studied the benefits of WCAG 2.1, not just basically in web accessibility, but also adding the support in design systems. And there are significant benefits to that. One of them is enhanced user experience for a broader audience. WCAG 2.1 extends the accessibility considerations of WCAG 2.0. It also, by adding WCAG 2.1 into design systems, developers and designers can create websites and applications that are more usable and inclusive, thereby reaching a wider audience. This inclusivity is not only a moral imperative, but also expands the potential user base, which can be particularly beneficial for commercial websites. The second benefit is increased compliance with legal standards. Many countries have adopted stricter regulations regarding web accessibilities. There are universities and their websites which are strongly just ensuring that all their students which may be impaired, may have some partial disabilities, their applications and university websites, they are compliant with the accessible standards, ensuring that they they basically are reaching a wider base. This proactive approach can prevent potential legal challenges related to accessibility, which can be costly and damaging to an organization's reputation. This also ensures, this pertains to the fact that organizations or government entities do not get sued by not adhering to it. The third benefit is enhanced search engine optimization and online visibility. In this, search engines increasingly favor websites with higher accessibility standards. WCAG 2.1's focus on clarity, navigation, and responsiveness contributes to better search engine optimization. Websites that adhere to these guidelines are likely to rank higher in search engine results, leading to increased visibility and traffic. Now, you can, by adding this, you are also support of WCAG 2.1 to design systems. You're also future-proofing web assets, including, a mobile and emerging assistive technologies. It also ensures design systems are better prepared for evolving technological landscape, and web assets remain relevant and accessible as new technologies emerge. It also enhances your brand image and corporate social responsibility. By adding WCAG 2.1, an organization would demonstrate its commitment to diversity, equity, and inclusion. And it also basically, to its potential customers and partners, it enhances the organizational and it demonstrates the organizational values, accessibility, and inclusivity. It also reduces the maintenance and development cost. Yeah, and so now speaking specifically to how do we migrate a design system from WCAG 2.0 to 2.1, the migration process entails a systematic approach to aligning the design system with the most recent accessibility requirements. The first step actually in the migration is ensuring, evaluating your system with the current compliance. Because WCAG 2.1 is built on a solid base of 2.0, the first step is to assess that whether an application is compatible with WCAG 2.0. So as part of that, what we will be doing is, we need to assess for a particular web application and all its components. Specifically for a design system, you're looking under components, colors, several guidelines beneath that, and you basically run it against WCAG 2.0 guidelines. And there are several browser tools available, like Chrome DevTools, which has a lighthouse, and you can run certain audit scans. You can run scans on examples code, and there are several resources and test procedures that you use, including black box and white box testing. We will also detect accessibility difficulties like semantic markup, the HTML markup, the practices, ensuring that they are, they are semantic, and they are as per W3C best practices. And also we will do manual testing as a first step, across the design system components. The next step after we figure that, what are the deficiencies with WCAG 2.0 in the design system, and after fixing them, is to now identify the appropriate success criteria. This pertains to the graphic that I showed before, which basically spoke to the 17 new success criteria, which were part of WCAG 2.1. And specifically, there were 7 criteria added under WCAG 2.1 AA guidelines that we will be looking up to add support to the design system. This approach will encompass detailed methods, timeline, designated roles and responsibilities for the migration process, and potential impacts on continuous design and development activities. It is important to prioritize accessibility improvements depending on their importance and urgency. For example, responsive support below 480 pixels. So a good example, and I will do a demo for that. So when you basically, if the viewport is less than 480 pixels, does the app design system adapt in the components? Does it offer high contrast support when the operating system forces colors? Or is the color contrast ratio compliant? The color contrast ratio is 4.5:1. And whenever the application is under 400% zoom, does it still adapt? To achieve these revised accessibility standards, we may have to modify or add code and interaction patterns to our design systems. And the underlying technologies that we will use as HTML5, CSS3, and JavaScript. Now, several organizations have successfully transitioned from WCAG 2.0 to 2.1. There have been case studies that this research studies. For example, Microsoft adopted, and added support for WCAG 2.1 to its Office 365 and Windows suite of products. BBC also prioritized mobile accessibility and addressed cognitive disabilities through simplified language and navigation. Now I'm going to run some demos to understand how does an application look before we add the support for accessibility. So here's basically one application. This is before, which speaks to the responsive design. This is an application which is not WCAG 2.1 compliant. Now we are looking at this application in this viewport. Now, if I just fold the viewport, as you can see, some part of the content is not visible and a horizontal scroll bar is introduced. So this basically is a violation, and several of our impaired users will never know that they are unable to see content actually, though a scroll bar is available, but that makes accessibility significantly difficult for them. And also, if this basically if the same device is opened on a mobile device, same web page is opened, what you will see is for a particular older device, say an iPhone SE, or say there are several devices which will, again, it will crop, or this basically the navigation on the right side will not be visible, though I'm unable to reproduce this. Now, as a fix, actually, what we could do to enhance this example, we have a responsive version of the same example. Now, I'm testing this interface. As you can see, the entire interface adapts. This is an example of the responsive, adaptable guideline being added support to this user interface. And the right navigation adapts by collapsing underneath the content. So ensuring that the impaired users can still access this information, whether they are using a mobile device, or a device with a smaller viewport. And for that same example, one of the essential, changes which were made by, which have to be made is basically, in this case, as highlighted in this example, is being used, they are using a CSS3 media queries. These media queries target certain examples and nodes actually in the source code, and then they basically adapt, so in this case, it's adapting to a viewport of 1000 pixel. And in this case, it's a 700 pixel, and it's adding certain basically classes, which will ensure that these certain these HTML containers, they collapse. We also have certain examples, other examples that we can look at, very popular examples, for example, apple.com, which basically, in this case, as you can see in the desktop mode, the same website would now basically support responsiveness and reflow. As you could see, the navigation collapsed under, and then the same navigation is available, under this hamburger icon. Even the content has adapted, making this entire website more accessible for for a large audience and also for impaired users. Now, speaking towards the role of the manual automated testing in the migration process, the significance is ensuring that the design systems ensure to the most recent accessibility standards. And it's critical when migrating from one set of guidelines to WCAG, from one set of guidelines to another, such as WCAG 2.0 to 2.1. These automated tools are helpful for finding common accessibility concerns, whether the first step, as we spoke, WCAG 2, finding if it's basically accessible for WCAG 2.0, And then after it is 2.0 compliant, doing testing to ensure what are the deficiencies for the WCAG 2.1. And then after the support for 2.1 is added, ensuring that, hey, all these, they have met the specifications after adding the support. So there are several tools as part of that we can use, like Chrome Lighthouse, W3C validation service, the WebAIM contrast checker, and the Wave tools. So one example of this tool we can run is we can use the dev tools, the Chrome dev tools, and specifically it has a widget for Lighthouse. That's one of the automated tools, and we can run an accessibility audit on this website specifically. So I'm running an accessibility audit. What it's going to do is it's going to run an audit, and it's going to basically publish a report speaking to the several deficiencies. So that's one tool. We also have WebAIM's color contrast checker. This tool specifically looks at, given two colors, say the text of a color and the background. For example, this two pieces of text. So this black color on a white background, it will then evaluate the color contrast ratio. The color contrast ratio for WCAG 2.1 AA is 4.5:1, and it gives out the ratio. So we get to know whether it's passing the color compliance. There are several other automated tools which help us in basically figuring out the deficiencies and helping us basically achieve WCAG 2.1 compliance. It is manual testing is an essential component of the accessibility of the review process, because automated testing may not cover every criteria for the design for ensuring WCAG 2.1 compliance on the design system. It is also critical to examine each design component in the design system example through the lens of accessibility during manual testing. Now, there are several challenges one may face when doing the WCAG 2.1 migration for a design system. One significant source of concern is the resource strain, both in terms of time and labor that will be necessary for the complete evaluation and accessibility of the new success criteria. The second one being the organizational culture's resistance to change, which may prevent the seamless adoption of WCAG 2.1 recommendations. Also, addressing potential complaints necessitates a proactive approach that includes strong communication, resource planning, and ongoing training to promote a joint commitment to the long-term benefits of improved web accessibility. Now, we also important to set realistic expectations and a phased implementation strategy to allay fears, promoting a smoother transition and long-term compliance while respecting the nuanced challenges that companies may experience in their pursuit of improved web accessibility. And speaking to the future work for this research, future research could address the intersectionality of accessibility, considering varied user requirements and experiences beyond the mentioned disabilities. While the handbook, while this research promotes collaboration, more significant inquiry into efficient interdepartment cooperation and communication tactics during relocation could boost its practical application. So in conclusion, upgrading a design system from WCAG 2.0 to 2.1 signifies a considerable commitment to encouraging diversity and user-centric design in the changing field of digital accessibility. These insights offered in this research emphasizes that upgrading to WCAG 2.1 represents a transformative journey, one that closes the accessibility gap while also aligning with the larger objective of a universally inclusive digital world. Furthermore, it positions companies and developers to effortlessly move the future accessibility standards into future accessibility standards like WCAG 2.2 and 3.0. And this is because 2.2 and 3.0 are built on top of 2.1, ensuring that digital experiences continue to improve in a way that benefits all users. At this moment, while we speak, WCAG 2.2 was, a final draft was released in October. So 2.2 is already out. Through WCAG 3.0 standards are currently in progress. Any questions?